Okay, so today we're going to review the materials and look at the chapter quiz review, and then see if you have any questions about the test. Okay. So since we only have 12 questions, we can look at the questions one by one. Okay. So first one said about the definite integrals, and that gives the area of the region. The first function y1 equals x power 4. Second function y2 equals x power 5. We need to find an area between these two curves. So first we draw the picture. X power 5 is going this way, so x power 4 is this way, but they only have one part. Okay. So we're looking at the area between these two curves. All right. So how do we solve this one? We find the area between these two. First, we find the intersection points. Okay. So first we'll look at this picture, x power 4, x power 5. How do we find out the intersection points? So you got x power 4 equals x power 5. Since the intersection at the point, they have the same x value and then under the same y values. So x power 4 equals x power 5. You have x power 4 minus x power 5 equals 0. You factor x power 4 out and you have 1 minus x equals 0. So you get x equals 0, x equals 1. So now we know the boundaries for this one is 0, 0, and 1, 1. Does that make sense to everyone? Yes? Okay. So now we need to find the area between these two curves. And then the area is going to be from 0 to 1. And we use the big function minus small function, the big value minus small one. So between when x from 0 to 1, x power 4 is bigger than equal to x power 5. Okay, so you need to use x power 4 minus x power 5. If you are not sure which one is bigger, you just try one number. For example, 1/2. 1/2 to power 4 minus 1/2 to power 5. You can see that 1/2 to power 4 is bigger. Okay, then you solve for this antiderivative. You got x power 5 over 5 minus x over 6, and plug 0, 1 into it. So you get 1 over 5 minus 1 over 6 equals 1 over 30. Does that make sense to everyone? Yes, everyone? Yes? Okay. I hope you don't have any question.
On the test, can you use a graphing calculator to calculate your intervals? Or do you want us to write them out?
Well, if it's a simple ones, I want you to write them out. For example, x power 4 minus x power 5, that's just a... Yeah, any polynomial which you can definitely find the integral, you should try it. Okay. Yeah. Okay? So like this kind of antiderivatives, you should be able to do that by yourself. Well, you can use the graphing calculator test to answer. For example, you get a final answer is this, right? You can use a graphing calculator to verify, if is my answer right or not. Gotcha. Right? Okay. So the second one...
Sir?
Yes?
I have a quick question on this one.
Uh-huh.
So, would you suggest that we always set the, equations equal to each other to find the limits? Or is it okay just to look at the graph if we can see the points of intersection?
Oh, in the test, probably I won't have the graph for you. Well, if it's a question like this, it might not have a graph for you. You have to set up them equals to each other. Does that make sense?
Okay, thank you.
Yeah, you need to set up the two functions equals each other, find out the 2 points. Okay? So does anyone have any question about this problem? Everyone okay? Yes? Okay. Next one. Determine which value best approximates the area of the region bounded by the graph of f and g. So this one is going to be very similar like what we did for the above one. You can set up, you can use a graphing calculator actually to which value the region bounded by f and g. So you can, it says, make your selection on the base of sketch the region and not by performing any calculations. So basically ask you to find out to do an estimation, okay? You can set up 7 minus 1 over 7 over x. So which is y equals this. The second one is y equals 7 minus square root of x. And you set up them equals each other. So 7 minus 1 over 7x equals 7 minus square root of x. If you draw the picture, I think the picture is 7 minus square root of x. Square root of x is like this, but minus is like this. Up 7, so it should be like this. And up to 7 minus 17x. Suppose this is a 7. Suppose this is 7. The intersection at 7, 0, 7 for sure. You should have another point here. Okay, so set them equal each other. You have 1 over 7 x equals square root of x. Okay, so if we square both sides, you have 1 over 49 x squared equals x. So solve x equals 49. Yeah, 49 and x equals 0. It's very easy to find this. You can reduce 1 over x, which is 0. When it is not 0, you can reduce x, and x equals 49. Does that make sense to you? So actually, the intersection point is 0. So it's like here. It's like here. Okay? This is 49. This is 49, 0. And then this is 0, 7. So it says estimated. Well, this graph, we can do a quick estimation. And the area between this, the area of this triangle is 49 times 7 over 2. So which is what? You can do an estimation, which is 25 times 2. You can use a calculator. How big is that? So 24.5. You can use a calculator. 24.5 times 7.
171.5.
171.5. Okay, thank you. So you can estimate that this app actually for sure is going to be, I think it's close to this one. This one, okay? Because this is too big. This is part of the triangle, right? This is too big, and this is kind of like small. I'm not sure if it's this one or this one. So you can do an estimation, and I can do it. If it's not this one, it will be this one. But you can do it, actually do the calculation of 7 minus 1 over 7x from 0 to 49, and minus 7 plus square root of x dx. Okay, so you do 0 to 49. The 7 canceled out, so it's square root of x minus 1 over 7x dx. Take the antiderivative, so this is going to be x to the power 3/2 over 3/2 minus 1 over 7 x squared over 2. Question?
Wouldn't you put brackets around the 7 plus square root of x and then negative will distribute?
Yeah, because there are two functions.
Yeah.
It's supposed to be this function minus that function.
So wouldn't it be the negative square root?
Yeah, inside is like this.
Oh, just kidding. Never mind.
Does it make sense?
Yeah, you just do.
Yeah, you subtract these two functions. Because this is a one function, subtract another function.
Yeah.
Okay.
You just do the math on it.
Yeah, so then you plug it in.
Yeah.
You can find the value. It's either this one or this one. I'm not sure which one yet. Okay. Might be this one because you plug 49 into here, so it's going to be 49 square root of 49 to power 3 over 3 halves minus 1 over 7 times 49 over 2 here. This reduces 7. And this will be cube 7 cube times 2 3 minus 2 over 7. It might not be exactly, it says approximate, right? So estimate, use a calculator, find this. It's either this one or this one. This is about 2/3 of 49, 200, 100. I think it's this one. Okay. Alright, so next one. In the test, if I give you the function, it might be easier function, not like this estimation. You would have like functions good numbers. Okay, not like a number is not very easy to calculate. Should be easy calculating. Since we only have 1 hour test, so that if you know how to do it, the calculation should be fine. Sketch the number 3. Sketch the region bounded by these graphs of functions. You can see this one, f of x is square root of x plus 9, and 1/4 of x plus 9. Obviously, it's going to be d, yes, because they intersecting at 9. So this is negative for sure, no. Negative, no. Positive, but it's square root of x plus 9, so it's this way. Square root of x, so it's d. Okay, and find the area of the region. Find the boundaries between these two. This is find the intersection point here. Subtract it. It's the same way to do as this one. Okay. Does it make sense? Okay. So you can do exactly the same thing like this, like the previous example. All right. So, do you have any questions so far? No. So you solve these boundaries. Set up them equals each other always. Okay. So you can set up these two equations equals each other. Square root of x plus 9 equals 1/4 of x plus 9. Solve that, 9 canceled out, and square root of x equals 1/4 of x. Square both sides, get x equals 1/4 of x squared. Okay, so since x must be positive, so I can square both sides. Okay, and I square this. You can solve that. You multiply both sides by 4, so it's 4x equals x squared. So you get x squared minus 4x equals 0. You solve that, x minus 4 equals 0. You get x equals 0, x equals 4. That should be okay for you, right? Does that make sense to everyone? You set up these two equals each other, you should be able to solve x. That's just a easy calculation. After you do that, you just take the boundary from 0 to 4. Obviously, square root of x plus 4 is bigger. Minus 1/4 of x plus 9 dx. So far so good, everyone? If you think you have trouble with it, you can go back and watch the video again. After this class, I recorded this video, I think. Let me check. Yes, I did. Okay, you can go back and watch this video again and also take some notes. Okay. So you subtract this 2, you cancel 9 because it's minus 0 to 4, square root of x minus 1/4 of x dx. So you subtract those two, antiderivative of square root of x is just the x, this is x power 1/2. So antiderivative of x power 1/2 is x to 3/2, add 1 on the power, divide by the new power. Minus 1/4, antiderivative of x is x squared over 2. Plug 0 and 4 into the formula. So you should have, the answer is, you can calculate that by yourself, is 2/3 and 4 to power 3/2 minus 8 to power 4 square, which is 16, and minus 0, because plug 0 into both is 0. So solve that, it should be equals 32 over 3. Because this you can reduce it, is 2. Okay. So far so good, everyone. Do you have any questions? Huh? Good? Everyone? Yes? Okay. Number 4, find the volume of solids generated by revolving the region bounded by the graphs of equations about y-axis. So this one you need to draw the picture first. If we draw the picture, you can see y equals 25 minus x squared. It's a parabola. And y equals 0 is x-axis. This is y-axis. This is y equals 25 minus x squared. And this point is 0, 25. This is 5, 0. Okay. You can see 25 minus 25 is 0. Okay, now you have x equals 4. So it's from here and also here. So we're looking for this area, this one. You revolve this with respect to y-axis. Question?
X to 4 to x to 5, so it would be 2 lines.
Yeah, like this.
Yeah, oh, sorry.
Yeah, and then it's this line. You have this line. Let me say this line, and this curve, and this line. So 4 of them bounded by this region. Does it make sense now? Mm-hmm. Okay. Okay, so basically we're looking for the we're looking for, why it doesn't work? We're looking for the volume. I like this. Revolve this part with respect to y-axis. Okay, so we can use shell method. I think it's easier for us to use shell method. Okay, because you revolve this, you go to another part. Right, we use the shell method. What is the shell method? Shell method is V equals
pi times 0 from here to d of y, h of y.
2 pi.
2 pi.
Yeah, 2 pi r times h, because the cylinder here is 2 pi r times h, right? You're looking for that, the area. So let me see. We can use let me see, y, what is h is this, x. Okay, do it. So 2 pi, what is r? R is x value, right? X is x value. H is 25 minus x squared. 2 pi r times h from 4 to 5 and dx. Does it make sense to you? Yep. Okay. All right. So you can go back, and I think this one is 512 pi. I'm not sure if it's or if not. It might not be. Okay. There's different answer. You can go back and check this one. Use a calculator. Okay. So what that is? It should be easy one. 2 pi r times h. As long as you draw the picture right, it should be fine. Okay, so number 5. Everyone good? Any question? No question? Okay. So number 6. Use shell method to set up the value integral that gives a volume of solid generated by the y equals. Oh, number 5. Set up a value integral that gives the revolve region about x-axis. So since it gives you this, it says revolving about x-axis, and you have this is y equals negative x plus 6. You can see, since revolve x-axis, we're gonna have this is, if you draw a picture, it's like this. Okay, so we can use disk method on this one. So r is y values, so v equals pi from pi r square dx. Yes. Okay, so now what is your r? R is y values. Okay, so r is y values, a to b. That's the disk method. So v equals pi. So look at the r function. R is y values, and y is starting from 0 to point which is 6, and then negative x plus 6 square dx. Does it make sense to everyone? Yes? Any questions?
I have a quick question in general, just because I seem to keep confusing myself on this a little bit, I think. So anytime we revolve around like the x-axis, then we're going to use like the x version of all our equations, correct?
Not exactly. Well, it depends on the shape. Look, you can look at this this representative rectangle. So if you revolve this with respect to x-axis, you can see there's a disk, right?
Right, and it's vertical. So we're looking for vertical versus horizontal?
It depends on what shape it gives you. Okay, if you revolve this with respect to x-axis, you can see that it's going to revolve a disk out. It's kind of like this. You revolve this, you're going to have a disk, a foot like a disk, right? Because you just use a pen, revolve one like with respect to x-axis, you can see there's a disk, right? If you respect this part with respect to y-axis, you can see it will give you a cylinder. Yes?
Yes.
Yeah. If you revolve with respect to about y-axis, you can see it gives you a cylinder. You use shell method. If you revolve this represent a shape, represent a triangle about x-axis, it will give you a disk. Does it make sense to you?
Yes, that part does.
Yeah, then it will tell you which formula you use. I guess in my test, I probably said which method you need to use.
Doesn't make a cylinder when you rotate it around the y-axis?
It doesn't? It does.
You make a cone, right?
We're going X all.
Yeah, like, you said an example, I think What is that?
Y-axis.
Is it extended?
No. Okay, you can use your pen. Use your pen. Revolve one y-axis. No. Vertically,
Oh, okay.
like this way. This is your pen, right? Like look at this. This is vertically this way, right? Revolve it y-axis. Right? The bottom is going to be a circle, but it's going to be it will give you a cylinder.
Oh, like specifically for this guy.
Oh, not the whole thing. Yeah. The whole thing will give you this whole thing will give you a coin. Yes, but I'm talking about one representative shape. Even if you do that, this one also give you a coin. If you revolve with respect to x-axis, it also give you a coin. But I'm talking about the revolving part. Does that make sense to everyone? Oh. Someone is using a cell phone or something? Okay. The noise coming back. It's okay. Okay, so do you have any questions, Caitlin?
I'm not pretty sure. I might have to just email it. It might just be kind of me confusing myself. But
You may go back home and try it and do it. I don't know. I'm not sure if you have done these questions yourself. You probably can try it and watch the video again. See if the setup formulas make sense to you. Okay. I think I have set up all the formulas, formulas for each question. You can just go back and watch the video and see if these formulas make sense to you or not. Does that help you?
yes, thank you.
Yeah. Okay, so number 6. Use shell method. You see, it tells you use shell method to set up, evaluate the integral that gives the volume of the solid generated by revolving the plane region about this. So first we have number 6. Y equals 25 minus x squared, and y equals 0. So if you draw the picture of this one, y equals 25 minus x squared is going to be a parabola open downward. And this is 5, 0. This is 0, 25. That's no problem for you. When x equals 0 is y-intercept, and y equals 0 is x-intercept. Okay, so now y equals 0 is the x-axis y. Now it says use shell method integral this, find the revolving volume. So it's about y-axis. If you revolve it about y-axis, use shell method. We're gonna have the picture like this. Okay. Okay. So now the r, the function, the formula is 2 pi a to b, 2 pi r x. 2 pi r times h is your cylinder dx. So v equals 2 pi. The x is from 0 to 5. So rx, which is the height, which is your y values. Okay, so r is x. Height is 25 minus x squared dx. Does it make sense to you? This is 2 pi. The r radius is, this one is the x value, and this is the height, which is the y value. Is a cylinder. You add all the cylinders together is your volume. This is the shell method. Is all the shell together. 2 pi x times h. Okay, which is the area and times the height times the delta x. So 2 pi x times height is h, is y. And you solve this is 2 pi from 0 to 5, 25x minus x cubed dx. Then you solve this one, you get v equals 25 times, 2 pi times 25x squared over 2 minus x4 over 4 plug 0 to 5 into it, and you can solve that. Should be easy for you. Does it make sense, everyone? Yes? Okay. So number 7. Use the shell method to set up and evaluate integral gives the volume of the solid generated by the plane about x-axis. I think we have one of this in the homework. So first we need to find a point here, which it gives you 5, 0. This one would be 9. You need to find out this point here. So when x equals 9, since y equals 5 minus x, so x equals 9, y equals, what is y value? Y is 9. Plug 9 into here. You got 5 minus 9, so it's 5 is 9, negative 4. So we revolve it about x-axis. You draw the picture. Revolve about x-axis is this way. You're gonna have a cylinder like this. Okay. Okay. So now the v equals, if it's shell method, 2 pi r times h. Because you're always thinking about shell is base times the height. The base is a circle, 2 pi r. Height is a h. There's 2 pi r, a to b, r times h. I think here the y it should be y because, well, the r is vertical. If the r is vertical, it should be ry times hy dy. Does that make sense to you, everyone? Yes? Since the r is vertical, so you use ry. Now, 2 pi, and what is your, here the values is from negative 4 to 0. So it's negative 4 to 0. Okay, now the r is y values, so just y, negative y, times the height, solve for x. Okay, solve for x, and I have to subtract it, I think, okay, because the height from here to here is 9. The whole thing is 9. Okay, the whole value is 9. But look at here, and I can give you an example. If you look at this, the whole thing here is 9. We are looking for this part. Question part, the green part here. We're looking for this part. The whole red part is 9. And then we have the yellow part, which is your x value from the graph. So we need to use the 9 minus the x value. Okay, so it's 9 minus x. From the picture, we can solve x equals 5 minus 1. Because y equals 5 minus x equals 5 minus y. So 9 minus 5 minus y and dy. Does it make sense to everyone? You didn't pay attention?
Maybe not just for a second.
Okay. I'll explain again. Alright. I would like to ask another student, say maybe the other student doesn't get it too as well. So can anyone tell me how I got the 9 minus here? Any volunteer who has paid attention, who will understand it? Do you have any volunteer?
So basically, you just like try to find the height of the triangle, which goes like the maximum is it goes from start from 5 and goes until 9. And we just need to get rid of the x values, which are like before 5. So that's why we just like get rid of them by subtracting the whole like length of the maximum length of the x, and we just like Yeah.
Okay, that's good. That's fine. All right. So now, thank you. So you can. We're looking for the height is no problem because we use 2 pi r times h, right? That's the formula. 2 pi r times h and multiply by the delta y. So r. If you look at this cylinder, the r is your y values. The cylinder is basically draw the cylinder. Cylinder is like this way. Okay. So the r is vertical way, so it's your y values. Is r is y. What is the x value for each cylinder? This is your the height, which is the horizontal way. We're looking for the this part. Okay. So how big is this part?
Okay. Oh, it's 9 minus that.
So how big is this part? The green part. How big is that? So you use the whole thing is 9. From here to here, this is 9. Yes. And from here to here, which is x value defined by the function. So this, because this x value is x equals 5 minus y. Because at this point the x value is defined by a function. Does it make sense?
No.
So if you use the 9 minus the green x value, it give you this question mark part.
That makes more sense.
Does it make sense?
Yeah.
Yeah.
And then that negative y comes from the fact that the function's below the...
Yes, below the y values.
Okay. Got it.
Does it make sense to everyone? It's okay. Does this make sense to everyone? Yes? Yes? Okay. Okay. Sure. Okay. So because the y values, look at this, the y value is all negative numbers. It's negative 4 to 0, y is negative, right? And we want to find out the volume. Actually, it should be a positive number. So this negative y actually give you the positive y values. Does that make sense to you? Because of the noise from the thing. Does this better? Oh, I can't hear you now. Let me mute this. Okay, let me mute this. If you hear me better, let me know. Wave your hand. This better? Not better? Is it better? Not better? Okay, there must be a problem. I don't see anyone using the cell phone. Oh. Yeah, I'm not sure. But we have to let me see. Okay, this better now? Yes, everyone?
Significantly. Yes, that's much better.
Okay. Alright, so now, since the y values is take the integral from negative 9 to negative 4 to 0, so the negative y will give you, since the y values, look at the y values is all negative, the negative y will give you a positive number. This will be this is a positive. This is if you put a negative in front of y values is negative. Negative is positive. It will give you a positive volume because the volume can be negative. Does that make sense to you, Caitlin?
Yes.
Okay. All right. So if in the end, for example, you forgot a negative sign in the end, you might want to check the problem again. Okay, check your negative sign stuff. Okay. This one, number 8. Number 8. Okay. Find the arc length of the graph, the function of the indicated interval. So I will ask you, one student tell me the arc length formula. S equals a to b something dx. Okay, I'm going to ask one student, and you want to tell me. I want to ask another student. April, could you please tell me what's the arc-length formula?
F prime, the square root of 1 plus f prime, or fx prime squared.
Very good. Thank you very much. Okay. You must memorize this formula. From A to B, square root of... That's terrible. You can't hear me anymore, right?
Tell April I'm on the mic.
Huh?
I think it's your mic.
Okay, April, could you move your mic a little bit? April, could you move your microphone? Yeah. No, you move your microphone. Yeah, it's your problem. It's your microphone.
See, when she moves it, it makes
Yeah,
sense.
now it's better, right? Okay, maybe I'll just very cautious ask you questions. Alright, so now, since y, here would you have y, if you know the formula, y equals 1/2 e to x plus e to negative x. So we take the derivative y prime equals, since we only have very short time, I want to go fast, I'm not going to ask questions, okay? Y 1/2, derivative e to power x is e to power x. E to negative x is e to negative x, but it would have a negative sign. Now just plug it back into the formula. So you have s equals from 0 to 2 square root of 1 plus 1/2 e to x minus e to negative x square dx. Do you have questions? Okay. So s is from 0 to 2 square root of 1 plus 1/4 of e to x. E to x times e to negative x is 1 minus 2 plus 2x e to negative 2x dx. Okay, this s equals from 0 to 2 square root of 1/4 e to 2x. Since this is minus 1/2, add 1, so it's plus 1/2 plus 1/4 e to negative 2x dx. Okay, you must be very careful and really know from here to here. Okay, I don't have much time to explain it, but it's just the simplified 1 plus distributed and then add it, you will have this. From here to here is another important step, which is 0 to 2 square root of 1/2 e to x plus e to negative x square dx. You can see here is minus, and it's minus 1/2 if you distribute it. Now it's plus 1/2, it's plus. You go back home and do this one by yourself again. Okay? I say it again. Go back home and do this one again at home. Okay? You have my video, but you have to do it again. So 0 to 2. Anyway, you have your your chapter quiz. If you don't do it, if you don't know how to do it in the test, I can help you. Negative x dx. Okay? Have you taken any notes? You did? I hope you did. Okay. And so s equals 1/2 e to x plus e to negative x is itself, but you have to change that into minus from 0 to 2. So you get your answer is 1/2 e squared minus e to negative 2. Well, if in the end in the test they give you the question like this, give the answer like this, you're going to get all the credits. You don't have to continue to do it, okay? If you give me the answer like this, you get full credit. Yeah, if you punch in the calculator, give me the answer like 3.627, well, it'll be fine. Okay? Either one is okay.
So we have to solve it.
Yeah, you have to solve because this is either a simple integral. You can solve it. Yeah. So number 9. Let me see. We don't have too much time. Number 9, you can do that. I think you should be able to do that. Is set up a definite integral of the surface O. Use a surface area. So the surface area is from A to B, square root of, is pi, times 1 plus pi times r. Does anyone still remember that? F prime of x squared dx. Do you still remember the surface area? 2 pi, no, it's 2 pi times 2 pi r times, wait, let me write it, okay. So A equals 2 pi times x. Yeah, 2 pi times r over x, 2 pi r times the height. Okay. So for this one, you set up the area equals 2 pi, just from 0 to 3, and x cubed over 3, and this is your x, your r, your radius. Square root of 1 plus the derivative of 1/3 of x cubed, so it's going to be 3x squared over 2. That's the derivative. Then square and dx. So A equals 2 pi from 0 to 3, x cubed over 3, and square root of 1 plus x power 4 and dx. Okay, you can use U substitution. And the number 10, which is pretty simple. Does anyone have any question about number 10? It should be easy, right? You go back and find the example from your notes. Okay, should be very easy for number 10. It's not really a formula. It's just use the F equals K times D. You find the K, Hooke's law. Yes. Okay. I'll give you a quick way. F equals K times X. 350 equals K times 30. You solve. K equals 35 over 3. So now the integral is from 40 to 70. And the work 40 to 70, kx 35 over 3, x dx. That's it. Does it make sense to everyone? Yes? Okay. Alright, number 11, which you have to know how to do it, but I don't have time for that problem. Okay. You must know how to do number 11. And I think we do have this one in the class notes, right? Do you remember? Okay, you can go to D to L, find the class notes, find this problem, and do it again by yourself. Okay? You must know how to do this one. Just you must know. Okay, if you don't know, tomorrow you won't know how to do it. Okay, just let you know this. You will have a problem like this. Okay, so you must go back and find your notes and do this one. Okay, in the exam you will have a question like the 11. Okay, 12 it should be easy. You can go back and review your notes. 12 is okay. 11 is the must know question. You have your class notes and review that one. Do it yourself, okay? And also you are going to have 2 integrals in the test. One problem you need to use integral by U substitution. For example, x squared, x cubed minus 1 squared dx. For instance, you have U substitution. You just need to U because they have 1 degree less than the other one. U equals x cubed minus 1. And you can do du equals 3x squared dx. Yes? And then plug into it, right? And you also have a turbulent method integral, which is x cubed, for example, x cubed sine x. And you just do u in the dv. U is x cubed, dv is sine x. Take the antiderivative, 3x squared, 6x, and 6 0. Antiderivative of this, you do one by one. Antiderivative of sine x is negative cosine. Antiderivative of negative cosine is negative sine. And antiderivative of negative sine is cosine. So you basically, you do, just cosine, yes. You keep doing, antiderivative of cosine is sine. So you do this and you cross multiply, and plus minus. Okay. You have two integrals. One integral you need to know is this one, U substitution. The other one is Tabular method. Easy one, okay? Two integrals. So that's all for your test review you need to know. Go back home and review for the quiz and these two type of integrals. You will be fine for tomorrow's test. And good luck.